Thank you very much, and welcome everybody. Now, the talk tonight is going to be very different to everything you've probably heard in the past 2 days. I'm going to start at the very opposite end of the spectrum and really focus on the context, the environment of which science is used and manipulated to enhance athletic performance. I am on my own, my colleague is not here. Jumping on a flight from New Zealand was a bit of a strain to do that twice in 2 weeks, so he's making it soon. So I'm going to be presenting some of his data and ideas as well. But the idea today is really to start at that context and just show you some of the journey, the environment and the opportunity of which the UK particularly has been functioning to support athletic performance into London. Paul rightly mentioned that the Olympic Games are about to be hosted in London this year. It is 129 days to the opening ceremony in the Olympics and 162 to the Paralympics. All the work that's been done for this Olympic campaign is complete, finished. Our Olympic cycle for Sochi in the winter sports is halfway through its cycle, and planning for Rio in 2016 has already started. So a lot of sports are already thinking about their technical plans, their strategies, even before we get to London. That continuation is critically important, but it's important to put that in context because in the reality of a research project or a particular project where information's been generated, a bit of equipment's been developed, it's been used, tried, refined, individualized during that final phase. So we're already there, we're focusing above and beyond that. It's now time to focus and enjoy it, I hope, if everything goes to plan. Now, many of you may be familiar with the Canadian Own the Podium campaign. It was an attempt to use science and technology to seek a competitive edge. This was our attempt. We set this up last year just to put a bit of fear into the opposition and create that type of environment to welcome people to London and to welcome them to the opportunities and the communities they're going to meet. So for those of you who are not from the UK and don't have UK heritage, be prepared. Be very prepared. It's one of our secrets in terms of the innovation programme. In terms of my own perspective, I trained as a sports scientist. I would never say I was an exceptional physiologist, an exceptional biomechanist. I had lots of interest in lots of areas. I ended up doing a PhD in injury epidemiology, understanding risk in relation to the application of science. And that enabled me to move into probably an area where I probably describe myself now as being much more of an expert generalist. We know a lot about a lot, but where we have particular requirements and questions, we go to the experts to pull them together. What we tried to do is, in effect, manage technical innovations, research development innovations, impact on outcome and function. That's what drives us function. In our role, the best analogy is to look at it as the conductor of an orchestra. Sport come in as the audience. It's our job to try to put that orchestra together to answer that question they have, to solve that problem, to try to have an impact within a limited time period. Now, an Olympic cycle is 4 years long, but after an Olympic Games, typically most sports go through a culture change, a change of management, which often means their strategies and structures going forward, nothing tends to happen that year. For every competitive year, an athlete is training often 6 months of the year. 6 months is in training, and that provides the opportunity to try new ideas in a systematic way. Come Olympic year, often you've been selected, you focus on just refining as you go into the games. So in a very applied development end, you have a minimum of 12 months to try and apply anything different, and at best 24 months. So answering questions does rely on knowledge, existing knowledge, methods and approaches to try to move performances on in association with the coach. So just a little bit about the United Kingdom structure. It's complicated, but it will give you a feel of what sort of happens. We invest 100 million a year currently in a high performance system. That enables us to support nearly 1,500 athletes, 300 coaches, 250 practitioners, who support this system across a huge number of summer, winter, Olympic and Paralympic sports. It's a lot of money, but what it does, it buys people and facilities. And if you comparatively look across the world, it's similar to what the Germans invest and similar to what the Australians do. It's just our method is much more flexible in the way we invest that resource. So money comes in at the top level from government and lottery. One of UK sport's main role is to invest that in a strategic way to maximise medal return. And we also run a number of strategic programs in coach development, which is crucial at a high performance end. Athlete development, which is very much around the classic talent programs and talent transfer, but also in research innovation. And my role in that research innovation program is to problem solve by using science, medicine and engineering and being able to find the right solutions. So typically what happens, an amount of resource goes to a national governing body, such as British Rowing. They invest that money in their programme to take their athletes to competitions, to enable them to live and train full time. And they also invest in science and medicine services to support those athletes on a day-to-day basis. They also have a capability to explore, and they do that in partnership with their institute partners before they head off into an Olympic Games environment. So it's relatively complex because of devolution, but principally the sports at the centre, they control where they want to go and where they make the decisions, and they're accountable based on results. It's managed, it's monitored, and they're based on their return of what they deliver in major events. Before we had that system that we now have, which has only really been going for 10 years, it's relatively young, it is important to acknowledge the history that the UK has in sports science, and particularly in an applied sports science domain. The first real strategic approach to that happened through an old programme called the Sports Science Support Programme. 4 million was invested over 10 years, huge number of projects across a number of sports. And when I went back to read that prior to this conference, there's still a lot that we haven't moved on from, and particularly in the way we deliver science to impact behaviour and impact the way people prepare. In other senses, we moved on massively, and the UK is certainly at the forefront of that. But where we've come from to where we are today is miles and leagues apart, and it's certainly contributed to the growth that UK's on. So before we get into the context of how these things work, I was just going to give you a bit of feel of why it's important. Particularly if we look at high performance now, here's just some brief data to give you a feel that the number of nations now winning medals at the Olympic Games is growing dramatically. And we particularly see that from 1980 post-Moscow. So it's hugely competitive. There's a number of nations now, to get into a final of the 100 metres, you've got to be running below 10 seconds. It is hugely competitive. And that means exploiting opportunities with highly evolved, highly developed and trained individuals to provide that marginal gain is crucially important. What we've also seen is a massive growth in science, and this is just an indication, if you look here at the graph, of a bit of work done by Marco Cardinali, a colleague of ours, who just looked at the number of scientific papers with the keyword strength training indexed on PubMed. And again, what you see in that past period of time is a significant growth. Lots of countries are beginning to look at how they manipulate a training process to maximize athletic performance. GB's growth has been in a similar pattern. Lottery investment to enable people to live and train full-time really came into the system in '97, and it's no surprise for that period of time we've seen this significant growth. Beijing was an exceptional performance, achieved 4th in the medal table, and it's going to be the same target for London. But it is increasingly more competitive, but there's a structure and strategy in place to enable us to allow science to flourish within that domain. One of our significant challenges, or the significant challenges that applied scientists now face with the information technology, is the amount of information that's out there. On a recent trawl, approximately 50 million journal articles in press, 130 million books, and a huge number of websites which are significantly accessible. So as a coach, as an athlete, as a practitioner, this information is readily available to you, and you can constantly pick up ideas and opportunities to influence what you do in your practice. Some of that can be dangerous, some of it can be really positive, but it creates an environment in which you need to know how to filter that information to apply the right types of ideas and the right concepts at the right time. Just to give you a feel, we have this concept of the next best thing. Constantly new ideas evolve, they're thrown out there, they're used, they're applied, probably without the right foresight and the right types of questions to fundamentally know whether it's going to impact on a training process. Although these are just examples, you can constantly read about them, and one of our challenges is also managing that in the press. How they pick up on ideas, think it's the next greatest thing, the press are hounding for stories about interventions. And managing that in context of an athletic performance is becoming more difficult because of the availability now of the information we see. One of our ways of managing that is around this concept called the performance knowledge pathway. You can source information and knowledge, as we know, to help understand what's going on. But there is an increasing growth now in performance sport around miniaturized sensors and technology just to measure stuff. If you look at a McLaren Formula One car, they pick up over 300 sensors on the car at any one time. They're shipping 1 gigabyte of hertz of data on a regular basis during a race car. And that concept's beginning to evolve because technology is becoming readily available and it allows us to measure things. That doesn't necessarily mean it has an impact on outcome. But by putting a plan in place to extract and drive that in the right way, we may be able to make the right gains. And harnessing partnerships with the appropriate scientists with the right questions is really the way we need to move. For us, really, we fundamentally believe in this quote, which was from a guy called Arius de Jus, who talks about the only sustainable competitive advantage you can sustain is to learn faster than the opposition. If you look around the world, particularly in our field, whichever nation are competitors, most people are doing similar things. Information is readily available. It's your ability to ask the right question and to apply that in our cohort in the right way to fit within a training process. And that's about moving quickly in the understanding of the duration of an Olympic cycle and the opportunities you have. So speed is of the essence, and we operate at the development end where that's really crucial. But for us, that's what we live and die by, and that's where competitive edges can be sustained. So that's just to give you a bit of backdrop around the context in which we now function. The UK is a well-funded system. It's funded on the basis of delivering medal targets. Science, medicine and engineering play a crucial function to that role, but it's not without its challenges. And if we're going to continue to understand athletic performance at the very top end of performance sport, we still need to make some significant steps. Our approach to that really has been to take a two-pronged approach and to fundamentally look at that classic research and development pathway. So if you look at the time that it often takes for fundamental work to seep through to application, it can be anything from 20 to 25 years. It's our job in some respects to try to accelerate that, but also to take what we understand and observe from high-performance athletes during a training process to feed that back in. We've developed a number of relationships with the Research Councils UK at the fundamental end to try to use high-performance sport as a model for scientific endeavour. The UK Research Councils are really open to those ideas, but we've still got significant steps to take. BBSRC, for example, have tried to host some forums with us to present observations that we see to drive some of that fundamental thinking. But the UK sector is exceptionally strong, it's untapped, and by coming to these types of events, we can pick up on these ideas to see what we can do. So $3 billion per year is distributed among a number of research councils, and we absolutely believe that high-performance sport can provide a model to help our understanding in that domain. So, is an elite athlete an appropriate model for scientific endeavour? Well, Professor Paul Green have certainly outlined that sticking biopsy needles in athletes is difficult, but certainly if you can convince them of the value and benefit to their performance, it's much easier to go through that process. Our system's becoming much more mature and much more applicable, but it's got to fit in with their lifestyle. But they're not normal, or whether we're not normal. Here's just an image of one of our successful athletes. He's relatively strong. Access 600k for 6 reps. In 12 weeks later, through his training process, can exceed 78 kilometers per hour on a velodrome. That's pretty special, and his underlying physiology and functional capability is probably quite unique. That's probably why he's the best in the world. But he wins by half a bike length. So we know these standards are getting exceptionally tight, but can that type of model give us some understanding that may help the other extremes? In our relationship with the research councils, and there have been some beneficiaries from that work to date, it's been very much of trying to see how that can work. Often it's been shoehorned alongside existing strategies, health, wellness and ageing, which is popular in countries. But a standalone sport for us, we think, provides something unique, and we're constantly trying to exploit that. So at the other end of the scale is really where my role and most of my colleagues function, at the development end, trying to use and drive that knowledge to answer questions. And it's one of the areas, particularly in high-performance sport, that was missing before. There were some academic links to national governing bodies, but we now have this structure which is functioned to deliver that, but those links back into fundamental science are really crucial. So what does it look like? We have a number of work streams, and the title of the presentation was around the application of science, medicine and engineering, and particularly for some athletes where they are at the pinnacle of their career, such as the example I just shown earlier. Equipment engineering is now having a massive impact on performance outcomes. You'll all be familiar with the swimsuits and the impact that that's had on swim times, but athlete equipment and accessories can impact on performance. And we're able to harness those techniques. 85% of Formula One engineers are British. We rely on them to particularly work on those aspects of development, and a lot of that gets rolled out of competition. But a competition represents just 1% of an athlete's life. If you look at 4 years, they spend most of their life training. Competing is relatively small. So at that point, you would hope and you'd expect through a coaching and development process, they're at their physical best. And what you're trying to do is maximize the probability of them achieving that best at a games environment. And equipment provides one major role and enables us to do that. Spoke briefly about data and part of the knowledge pathway. There is an increasing trend for field-based diagnostics to measure function. So where an athlete is in their environment, it's taking them out of a lab and building and developing on the miniaturization of electronics, wireless telemetry, software and data mining to better understand that training process on a day-to-day basis. So this is just an example, and pretty much what we're able to do is borrow from Formula One concepts. And what this data does is often drive quite pertinent, targeted questions. So if you can just see in the top left there is a miniature data logger which attaches to the SRM crank, which people are relatively familiar with, but enables to sample at much higher sample rate. The athlete will go onto the track to execute a particular training session at maximal. By the time they come off that bike, that data would have been wirelessly transmitted, downloaded, and the athlete and coach will be able to have a sensible, objective discussion about the quality of that output to influence the ongoing training process. That's a big move across sport, trying to provide better data-rich coaching environments to inform the process on a day-to-day basis. And it, for us, is about function. So obviously a lot of mechanistic work going behind there, but the coach will manipulate the training process off the back of that data. Crucially, the most important area which is really relevant to this concept is an area of work that we call training science. And in a very simplistic way, you should all be familiar with this from your perspective. It is about the training model that a coach applies to his athlete on an individual basis to maximize their gain over time. And in a very simple way, where we measure function, however we may do that through these various sensor technologies, a coach's job, in effect, the way we discuss this, is talk about applying a training stress. And there are many variables in that: frequency, intensity, timing, type of training, which is put together with the aim, in effect, of overloading the athlete. So at any time we measured function, you'd expect to see some different results. And then in the idea that the athlete rests, recovers, adapts, so they're in a much better place. If the coach applied that same training stress before, they wouldn't expect to see the same return. But most of the questions that we get asked are about that process. And it's about also providing the tools to inform that process to be much smarter. So where we see concepts, these hot topics that arise, they need to be put in context with the chronic loading that an athlete goes under. For us, acute interventions and looking at those acute things are interesting, but it's how that's put together to develop training gain, which is what differentiates where the athlete resides. Now, when you get that process wrong, I'll come on to that in a second. These are just some examples of where we may look at breaking training plateaus. So how biomedical work is going to influence the type of practice. We're all familiar with hypoxic, but the use of occlusion cuffs, for example, to provide novel stressors. Those examples fit within this context, where athletes may reach training plateaus, how we use these tools to break that training plateau to continue their acceleration and development. So it's always in context with the training process. Now, where we get that wrong, inevitably, athletes break down. And a lot of work that we particularly do to understand athletic performance is just good injury risk assessment, understanding what goes on. And 30% of athlete absence from training is due to illness. Happens particularly at certain times of the year, unsurprisingly off the back of heavy training loads. Injury accounts for a significant proportion of that, as you would know from the stats, but actually most of that comes from the gym. Now, whether the gym environment is what's the hair that breaks the athlete's back, we don't know because of the loading, but that loading process is crucial. It is our biggest performance risk. It's the biggest performance risk for any athlete who wants to achieve the very best that they can. So it's a crucial bit of work in really understanding those interventions. And unsurprisingly, we have to try to solve those problems with science, medicine, and engineering. This is just a good example in the top right. We have a high incidence of injury in female sailors. That's a very unstable position. But simply by refining these harnesses, which are not developed for female athletes, you can provide much better support and reduce those types of challenges that you come across. So understanding the problems are crucial to ask the right questions and solve the right problems. And performance medicine, as we call it, is really focused by influencing that training process under that basis. So hopefully that gives you a bit of a feel that a performance sport is about everything. It's about coaching, it's about the athlete's desire, it's about engineering, it's about the sensor technologies, it's about understanding the training process. But fundamentally, what an athlete spends most of their life doing is training, how they scoped and put that process together to be the best they can over a 4-year period. So ultimately, they're at their physical maximum come Olympic Games Day, on that day and that time when it really matters. So what I'm just going to run through now, probably for the next 15, 20 minutes, is just a few ideas and concepts of how that's brought to life. It's very applied. Some of them's n=1, but just to give you an idea of some of the types of questions that get asked and how we try to solve them. So I'm going to focus on 3 things, very simple things, around competition preparation, which is really about maximizing the probability of achieving someone's best. Recovery, which is a very hot topic, but particularly around training in competition. But also just a little bit around pre-briefs and debriefs. That relationship between coach and athlete and a growing understanding of how that social environment can impact the underlying physiology is important for us. One sport that we're actually quite good in, winter sports, we're not a winter sport nation, is skeleton. Been hugely successful in the past 3 games. Skeletons really determines, most of the success is determined by how quick you are at the start, how well you drive that sled at 130, 140 kilometers per hour over 4 runs in 2 days. It's quite a simple sport if you're brave enough to achieve it. But in quite a cold environment, warm-ups become crucial. So typically what happens, if I get there in a second, an athlete will spend 20 minutes warming up. They mess around before a race, they go back, and by the time they come back out to push, their body's already cooled down. So their ability to maximize a start is often lost. So we did a bit of work around these guys to maximize their probability of getting a fast start, knowing that they're already exceptional, talented athletes. But where we look first to get some ideas and concepts is fundamental literature. Here's some data produced by Marco Cardinali, which is very much immersing a group of not elite athletes, but individuals in hot water and looking at the changes in the muscle characteristics in terms of power and capability. So that helps our thinking in terms of what's possible and how you can manipulate at a fundamental level. Some other interesting work that's emerged very recently from the group up in Aberdeen, Stuart Gray, around what happens when you change that muscle temperature in terms of muscle ATP turnover. So we do look at these things, but we'll refer to the experts to better understand what that may tell us and how we can take that concept forward. So where's it taken us? Well, in Bob Skeleton, you don't have a huge squad. This is the population that we have in the UK. 4 females, 4 male athletes, who are all very lean, light, fast athletes. As I mentioned, their standard warm-up, 20 to 30 minutes, wrapped up in big coats. As they get closer to that warm-up, they strip off, they wait, and then they come up and get ready to race. Now, if you just have a quick look at a time profile, now this is just body temperature, so we know the meaning of that, but this just is 1 female in red, and this is 1 male athlete. Just gives you a feel of the change in that temperature during their period of starting their warm-up. They finish their warm-up in a much better position, and when they actually go out to race. So they're exactly where they were when they started. If you actually go in just to manipulate that warm-up, very, very simple in terms of intensity, frequency of how that's done, you can increase performances. And if we also get them to wear some decent clothes before they race, they can also passively retain heat. And at a very simple level, taking some of those concepts enables us, as you just see here, these are 3 different athletes, athlete 1, 2, and 3. Look at their start time. Just during that downtime, by wearing some relatively warm hypothermic jackets and trying to retain some body function, they could improve their start time. And 0.2 on a start, because it's downhill, accumulates in terms of 4 runs. So it's very crucial in terms of what they do in terms of marginal gains. What about normal climates? We're coming into London. It's not going to be that cold. It may be. You never know. It could be as hot. We'll have to see. But what about normal climates? I think what fundamental literature tells us around body cooling to increase exercise capacity, but also passive warming to maybe increase muscle speed. What about if you put those things together? This is some data that's just been produced by Dr. Christian Cook with some colleagues around just some repeat sprint models. So looking at repeat sprints with a rest, but in that warm-up phase, trying to look at passive warming, passive cooling, but combining them to see if there's different mechanisms affecting function. Performance is always normalized relative to their best. And as you can see up here, the sort of open triangles in terms of cold, closed ones in terms of heat, and this is a combination method. If you just look at those improvements in time across those repeat sprints, heat, time will gradually get slower, cold, as you can see here, gradual improvements, but a combination of the two appear to improve capacity, but also single ability in terms of those sprint speeds. So a very simple concept that arose from the literature, which has been tried to look at functional return. And it just gives you an idea of how that sort of link comes together. Recovery, as we know, is a huge hot topic in sport. The use of cold water immersion as one treatment, among many others, has been used to manipulate the training process. Often, and the thought and the questioning behind that's been missed, and what we're actually beginning to see is the story is not as simple as we expect. This is just some interesting work that we picked up way back in 2006. It was in untrained subjects, but particularly looking at the impact of muscle cooling on the impact of adaptation. And at this time, it gave us the use of cold water immersion was one particular intervention and idea that was being tested. And it gave us an idea that actually the picture may not be as clear as we suspect it should be. So what happened functionally? Again, we're looking at function. This was a particular group of rugby athletes who are up for anything. After a simulated game, received either a passive treatment, which was a single cold water immersion, a passive treatment there, and also cold water immersion, which was 7 minutes, full neck immersion at 7 to 8 degrees. And what you're able to see acutely here, so obviously you have a very different response immediately after that game. So when given cold water immersion, as you see functionally, the athletes could maintain some aspect of performance. But over time, there was this crossover which we began to see. So actually, where you're looking to improve training gain through stimuluses, doing nothing may actually have been the more preferred route. So there is a crossover point of certain things that are happening at a functional level. Just taking that a little bit further, again, similar model, just normalized to a functional outcome, which for a lot of these guys is often a repeat sprint performance, 24-hour recovery. With a single bout of cold water immersion, you can maintain the quality of that performance. But looking at those gains over 3 weeks, it reverses. So this crossover, something's happening which, again, at a functional level is important to understand about the way people practice. Interestingly, there's some good literature and ideas out there. This is just some response looking at how that inflammatory process has been manipulated, and just showing that the use of cryotherapy and multi-exposures, how that influenced some of those responses. And this is just a little bit more detailed, done at a muscular level from Dr. Christian Cook's lab, looking at the changes in some of these markers, so free testosterone, cortisol, IL-6 and citrulline, with an exercise stimulus, and just tracking those over a 4-hour period. Now, when they applied a cold water immersion model, as you can see, the response is dampened. So there's a lot more context behind that, but again, it's beginning to line up with what we're seeing functionally about how these athletes evolve. So making sure we ask the right questions of the right people to get to the right answers is massively important. Now, one other practice common in sport is that of massage. Typically, you either like it, hate it, everyone responds to it in a very different way. And very recently, there was some interesting work out from Mark Tarnopolsky, which was looking at massage theory and the impact that has on inflammatory signaling. But it's something that happens a lot in sport. We employ a lot of masseurs to treat athletes, and there certainly appears to be some benefits to those guys. So there was a little bit of work that was carried out in looking at these different techniques. And if you work closely with team sport athletes, they either love or hate this type of stuff. We don't know whether it's real, whether it's a placebo effect, whether it's all about tender loving care, but people want to feel special. So a very simple model here of splitting up 2 groups of athletes, those who really liked this and those who didn't, subjected them to various treatments that have no massage. Massage from a familiar masseuse, somebody from a practice they work with quite regularly, somebody from a practice that they didn't have a personal relationship with, but also somebody they didn't know at all, but was probably very attractive to the male race. So they repeated the protocol 3 times and just looked at functionally their repeat 40-meter sprint performance. So they understand where that sits and what the signal-to-noise ratio is that functionally. So what did the results tell us? Well, if we look at those guys who like massage, and we're looking at functional performance, it just gives you a feel that obviously doing nothing, not such a positive response, but with a familiar masseuse, and predictably somebody they didn't know that well, you tended to have an increase in performance 24 hours post that treatment. If we take those that didn't like it, regardless of the treatment, so doing nothing, whether it's the familiar masseuse or unfamiliar masseuse, didn't do anything for them. But you throw in your curveball. There's obviously something going on here, which we can't quite yet explain, but man is an evolutionary object, the same in both sort of genders. So it's interesting how that link certainly impacts on functional outcome, but there's something underlying behind that, and it's something that's really driving some of our thinking going forward. Whether it's placebo or the athlete-coach intervention is certainly an area that when you're in acute competitive situations, that link between coach and athlete is a crucial ingredient. So coach-athlete interactions are crucial. You get to a competition, your athlete's prepared physically as best they can. We've used all the best knowledge about their training model, reverse periodization, conjugate. We've gone in all different directions. That coach-athlete interaction can make or break that environment. Psychologists talk about it. What we're trying to do is measure it and understand it. Unsurprisingly, some fascinating literature around the use of testosterone in this particular domain. I think there's some interesting debates that you guys will be better informed than I around testosterone as an anabolic function, particularly in muscle growth. But maybe it's much more than that. Maybe what it actually is, it gives the drive and motivation. Certainly in elite athletes, we see the availability of free testosterone being a strong predictor of your ability to produce power and strength. Maybe not in other cohorts, but certainly in that group. And it may be a trained response. But this concept around its link to the brain is one that drives that link and which coaches anecdotally talk about and which we seek to understand. Now in high-performance sport, because of the growth of technology, we can send anything to an iPad nowadays. The use of videos to brief and debrief individuals post those events are quite important. And this was just a short experiment by Dr. Cook and Blair Crew. They're looking at different priming with different videos and the response in a particular strength test. So a group of professional athletes watched these video clips, various different content prior to workout, and then had their strength assessed. There was a bit of publicity around this around Christmas time. I think it was a low media day, but they really got excited by the fact around this because of England Rugby's performance at the World Cup. But I'll just talk through this very, very simply. So 15 minutes prior to a squad assessment, they were shown a number of different videos. This reflects the change in availability of free testosterone and their relative squat performance. So they weren't big squatters, but twice body weight, which is, an average starting point. If you just look at the different exposures and the response in terms of their performance in T, you begin to get a picture. So there's the control situation. There was a sad video. What the press got interested, funny enough, with this erotic video because it timed in with the Rugby World Cup. A humorous video, but also something that was aggressive, particularly because these athletes are combative in terms of the way they function, but also a particular training video. So manipulating that environment prior to going to training may give people a better drive to get a response from that training effort. What about going into competition? Again, a similar example where particularly psychologists talk about the use of positive assertiveness, self-motivation or negative events. Now, if you show a negative video to an individual, what we mean by that is you're focusing on not that athlete. So in a hockey match, you're going to play your competitors, Argentina. What you actually do is with your athletes in that debrief before you go in, you talk about Argentina. You talk about how good they are. Look at what they do. Look at that exquisite skill. When you be positive, you focus on your athletes and what they're really good at. So it's the strengths. Look how good you are there. Look how you make that tackle. Look at that great tackle back. So when you manipulate those situations going into competition, KPIs here are their key performance indicators. So a lot of sports use performance analysis. They've got really good indicators of what will give them an outcome in terms of competitive event. And this is the coach's rating. So a low KPI is good. So what we began to see by manipulating those environments, you're able to change that physiological response. And what you certainly see is some changes in outcome. We're not saying this is cause and effect, but certainly what's happening up here, the link between brain and behavior is fascinating. So free T and effects are very situational, individual, and certainly training history independent. But from the perspective of a coach, what buttons they push, how they push them, how they set up that brief and debrief environment is really crucial. And I think the underlying biology and biomedical basis behind that is certainly providing some insights for the future. So those are just a few ideas, very simple applied things where we're trying to understand and where we lean and look towards biomedical evidence. But what is our greatest rate limiter for impact? Now, in most sporting systems, the coach and athlete own their process. They're ultimately accountable. To impact on behavior change, you need to get to that position, and how you go about that is where we can have greater impact with science. It's massively important, and one thing that we try to do to encourage that is some of the thought process behind this guy, Henry Ford, who said that if I'd asked my customers what they wanted, they would have said faster horses. So you don't know what you don't know, and you need to get into a position in a relationship where science can fundamentally underpin and impact that process. You can have that type of influence, and that's a real skill set that sometimes we manage to do well, sometimes we don't. His point very much here was people just didn't know about other ideas and other opportunities in their process. So creating those environments for us is massively important for impacting on behavior change, which is really at an applied end where we function and how we try to filter science through. It isn't that easy. Nowadays in a coaching workforce and an athlete workforce, we've got Generation Y through to baby boomers. Their fundamental learning styles are very different. Athletes are Generation Y, as are some coaches. They learn by doing, they learn in small snippets of information. So how we use science to influence that behavior change is really, really important. And this sums it up, really, in that not everyone does get the trophy. Now, typically, behavior change, there's a concept called Captology, which is really helping us scout those corners to influence how people think about their performance. There's a guy called Professor Fogg in Stanford that captured this, which is really about understanding the social interactions behind such things as Twitter, Facebook, iPads, why people encounter those technologies, why they use them. And that particularly is a clever, covert method of how to get science and to get people to think about their performance. Of course, it's not always as simple as that. I think what biomedical science tells us is it's never as simple as one thing works and one thing doesn't. There's always a balance. Here's some interesting work that came out of the Journal of Applied Physiology, looking at even an exposure to some of those types of technologies and the consequent impact. So always finding that balance is a really interesting process. But technology as a method of getting science into the right domain is one of our crucial methods. So I've given you a bit of feel about our environment, some of the challenges, just some small examples around the types of things that athletes ask, coaches are asking, how you go about answering those relative to the constraints of human performance. But it's not always about there, it's about going forward. And there are a number of ideas and concepts which we think are going to be fundamental to the way we think and understand and develop athletic performance. We spoke a huge amount around sensor technologies, rapid diagnostics, creating these data-rich coaching environments where we can truly understand and measure function, but also some of the underlying physiology that drives that function. We need to be able to predict and understand those changes in performance if we're going to move on. Some of these concepts provide some interesting ideas around embedding electronics, I don't know how ethical that may be, into the skin to detect various physiological measures. But certainly we've seen embedded sensors being used in animal sciences, and it may well provide a better understanding of the continuous nature of somebody's physiology. Certainly our understanding about responders, non-responders is one of the things that will continue to come up, and I think you're very fortunate to have two internationally leading individuals who'll be talking about that and have to have spoken about it. So these are just a few things which for us will help understand why certain individuals respond to one type of training and other individuals don't, yet they can be equally successful. Practicalities of a high-performance program tell us that a sport will have a training model that is successful. If you meet it and respond to that loading process, you'll be successful. If you don't and you happen to fall off along that journey, your opportunity gets diminished. Can we be smarter about understanding what type of responses, what type of responder you are, and how that will accelerate your development so you can be successful? It's about trying to get many more people up to the top by individualizing what we do, and it's the same at high performance as we talk about individualized medicine. I briefly gave you some funny examples of the link between brain and behavior, but again, this group in London, Keeler and Yarrow, have spent some time looking at those neural processes, and certainly what neuroscience is beginning to offer us in the future is exciting, I think. To be able to look at the human body in relation to function, brain, muscle tissue as a complete system, it certainly provides us with a great insight. Long way to go, but it certainly provides some food for thought. And this concept's arisen how you can manipulate aspects of the brain through transcranial simulation to increase learning. We spend a lot of time looking at the underlying physiology and adaptation, but for many athletes, they are hugely skilled. And motor acquisition and motor skill acquisition is one of the areas that we need to significantly tackle, and certainly some of the opportunities through neuroscience provide some foundations which may enable us to view that in the next 10 years. I spoke very briefly around this whole system, function, the underlying physiology with a link to brain. It's the sort of holy grail, how we understand how that body responds to stress. Again, this is something that caught our eye. I'm not going to be highly critical and assure that other people can look at this, but particularly looking at that link between what we call that mental toughness that is prevalent in high-performance athletes, and whether other ways of understanding the underlying biology behind that. All interesting concepts which, based on the questions we get asked from coaches, the ideas that they have, some of this may begin to unpick what they see in talented athletes and how those progress and how those that don't. So the last thing for me really is just to talk about science communication. We read a huge amount in the press, and certainly our British press are pretty good at this sort of stuff. They like to, as the Americans particularly are, I don't know how you can agree a win is 1-1. Going into London, one of our biggest pressures is managing the press and how they communicate and understand science and how they use that in the right domain. I mean, whatever literature you use, how we go about that equally externally is important, because we're all judged by impact, but also with our athletes and coaches, and making sure those concepts are well understood and the risk return is managed appropriately. It's a big challenge for us. Without a doubt, it provides a significant opportunity, not one that we're scared of, but expect to see some things in the next 6 months that'll be both positive and negative. Expect to see me on the back foot, expect to see my bosses on the back foot at time. We will fundamentally be judged whether GB achieve 4th in the medal table and our Paralympic team achieve 2nd. It's certainly possible, but managing those guys is also one of the challenges. They pretend they're your friends when they want to be. Just to really finish off, as most people do, there are a huge amount of people that I need to acknowledge. I speak about a team of 7 in our research innovation format, but we've got a cast of thousands, a number of colleagues, advisors, a number of other organisations that contribute to a UK system in supporting our athletes as they go to the top. It is significant. There's a huge number of people around, but science plays a huge role now in athletic development. And events like this are fantastic for us to come and listen, learn ideas, network, and meet individuals to see if we can find pathways and opportunities to exploit that. Thank you very much.